Hello everyone! In this calculus and linear algebra tutorial, we will learn the following topics. We will learn what is a minor of a matrix and how to calculate minors of a matrix. Then we will learn what is a cofactor of a matrix and how to calculate cofactors of a matrix. Then we will learn what is an adjugate matrix and how to calculate. And finally, we will state the formula for inverting a matrix by using minors, cofactors, and matrix adjugate. In my next video tutorial, I will do a few examples in order to illustrate how to use these definitions. However, in this video tutorial, I will only focus on the definitions and I will try to explain these very important concepts. Before I formally define a minor of a matrix, I will explain this concept by using an example. Over here we have a matrix A, and this is a 3 by 3 matrix. The entries A11, A12, A13, etc. can be arbitrary numbers. Now, the question is, what is a minor of a matrix? We will actually have 9 minors of this matrix, and every minor will correspond to a certain entry of the matrix. The minors are usually denoted by the capital M, and they also have the index I, J. That is, to every entry of our matrix, we assign the corresponding minor. That is, the entry Aij has the minor Mij associated with itself. Okay, let us see what is the minor M12. This minor is associated with the entry A12. How do we construct this minor? First, we locate the entry A12. Then, we do the following. We simply erase the row and the column to which this entry belongs. In our case, A12 belongs to the row 1 and to the column 2, and we simply erase the first row and the second column. Then we construct another matrix. I will call the matrix as A12 by using the remaining entries. So we take this entry, this entry, this entry, and this entry, and we construct a matrix A21, A23, A31, and A33. Okay, next, to compute the minor M12, we simply compute the determinant of this submatrix. And the determinant is A21 multiplying A33 minus A23 multiplying A31. And that's it. This is how we compute the minor M12. Let's compute another minor. For example, let's compute M32. The first step is to locate the entry corresponding to this minor. The entry is A32. Here it is. Next, we need to erase third row and second column. That is, we just look at the indices of our entry, and this entry lies on the third row and on the second column, and we simply erase the third row and the second column. Next, we construct the submatrix A32. Here it is. We take the remaining parts. A11, A21, A 1, 3, A, 2, 3. Next, we need to compute the determinant of this matrix. The determinant of this matrix is actually equal to our minor, and the determinant is obviously, let's write it nicely, determinant is A11 multiplying A23 minus A13 multiplying A21, and that's it. That's the minor M32. Next, let us formally define a minor of a matrix. For a square matrix, the Mij minor is equal to the determinant of a submatrix obtained by deleting the ith row and the ith column of the matrix. And that's exactly what we did. Over here, I illustrated once more how to calculate the minor of the matrix. That is, over here I calculate M12. Again, original matrix, erase row 1 and column 2, then form the submatrix and calculate the minor as the determinant of the submatrix. And that's it. Next, let us define a cofactor of a matrix. Here's the definition. The ij cofactor of a matrix, denoted by C with the index ij, is defined by this equation. What happens over here? We take the corresponding minor and we multiply it by this term over here. This term will give the sign to our minor, and in that way we will define the cofactor. The cofactor matrix is actually determined like this. We compute the minors M11, M12, M13 until M33, and we simply add the sign to these minors. So how do we add a sign? It's very simple, and let me illustrate it over here. For example, we computed M22. C22 is the corresponding cofactor. So what happens over here? We take minus 1, and over here we enter 2 plus 2. That is, we just add I and j indices, and we multiply the result by M22. Obviously, minus 1 to the power of 4 is plus 1, and over here is our cofactor C22. Perfect. Next, we need to define the adjugate matrix. The adjugate matrix is a very important matrix in linear algebra simply because the adjugate matrix is used to compute the matrix inverse. Let us consider our A matrix once more. For such a matrix, we can define the cofactor matrix like this. So we simply take all the cofactors and we group them in the matrix C. And this C matrix is exactly the matrix given over here. Okay, now we can define the adjugate matrix. The adjugate matrix of the matrix A, that is usually denoted by using this notation, ADGs, which is a shorthand notation for adjugate, is defined like this. So what happens over here? We take our cofactor matrix and we simply transpose this matrix to obtain our adjugate matrix. And here it is. What is a transpose of a matrix? Basically, we flip the rows and columns. So the rows become the columns. So let's see what happened over here. We take this row and we simply type it as a column. We take this row and we simply type it as a column. We take this row and we simply type it as a column. And that's it. That's the adjugate matrix. And finally, we can state the formula for matrix inversion. The inverse of the matrix A is simply 1 over determinant of A multiplying the adjugate matrix. 1 over determinant of A is a scalar, and we multiply a matrix and a scalar element-wise. That is, we take this scalar and we multiply every term of the matrix with the scalar. Okay, that's all for today. I hope that you like this video. If you like the videos I create, please press the like and subscribe buttons. Thanks a lot and have a nice day.